Hello students, in this video I will discuss the Gauss-Short theorem for a closed triangle. Because since it is closed, so that that theorem is extended to Cauchy-Gauss-Short theorem. That theorem is called Cauchy integral theorem or fundamental theorem of integral calculus. That there in that complex analysis there. So statement of this Cauchy-Gauss-Short theorem for closed triangle. A function is supposed to be analytic function in a domain is a triangle, then integration of f of z over the closed triangle, that is triangle, or the domain is triangle, that is 0. So now let us see that proof of this theorem is, now we have drawn that is triangle there. So let us take a function b. Let us assume that function be analytic inside that domain, triangle domain, and also that triangle you can divide it into the many sub-triangles by make use of the sides of the triangle there. So we get a 4 sub-triangles. So which is what respectively that delta 1, delta 2, delta 3, delta 4. It means what? Triangle 1, triangle 2, triangle 3, triangle 4. Then we can have that we can take the integration of z over the closed triangle is equal to the sum of those integration of f of z over that all those triangles respectively delta 1, delta 2, delta 3, delta 4 means triangle 1, triangle 2, triangle 3 and triangle 4. Then taking the modulus on the both sides, we obtain that is the, if it is by the properties of real analysis, so our real numbers, so that if we have that is magnitude of that integration of f of z over the triangle is less than or equal to the integration of the modulus of the integration of f of z over the triangle 1 plus triangle 2 plus triangle 3 over plus triangle 4. You can sum it all those integration of all the triangles starting from triangle 1 to triangle 4. Now let us take let each of 4 integrals on the right hand side, which can be denoted by integration of f of z dz over the triangle 1. So ultimately then this expression can be taken is, instead of taking 4 integration, we can take it, that is the, it should be less than or equal to 4 times of integration of f of z over the triangle 1. It is one and the same that. So now again this triangle delta 1, this triangle 1 can be divided into again 4 sub-triangles, and that can be denoted by delta 2 there, suffix there. Then we can obtain again, that is because it's 4 into 4, it's 6, that is the 4 square, we get it that. So this means what, we have a mean integration that should be less than or equal to 4 square into, that is integration of the f of z del dz over the triangle 1, that triangle, or else this triangle 1 should be less than or equal to 4 times of integration of modulus of the integration of f of z over triangle 2 there. You can continue to divide like this in this manner. So we obtain that is the that sequence of the triangles in such a manner that main triangle is always greater than the all the sub triangles we have divided there. So that is what that means. Main triangle is less than equal to next triangle first division, and next again we have a division of this triangle 1 can be into delta 2, so that in such a way that the main triangle is always greater than, that is the, whatever the subdivisions which we have made it there, that we have this manner we have a divided. So now this this inequality that satisfies, this is the relation there, generalization, that is integration of the modulus of that modulus of integration of f of z over triangle n minus 1 divisions of the triangle, it should be always less than or equal to the integration of f of z over the triangle n number of triangles there. So that means whatever that you can substitute there in that equation 1. So that means it is the first one, this one. So then it means what, that this is the modulus of the integration of f of z over the triangle. It should be always less than or equal to the, so that 4 times of 4 power n into, that is the modulus of the integration of f of z over the n number of triangles we have made the divisions there. So that is what there. So just we called it as equation 1. Now this sequence always, now we have a common point in that triangle. That common point is z0. That is that, which is the center of all that one. It means what, it is the common to all the triangles. So that now, since the sequence of that sequence of triangle delta n, which converges to that common point, which is a member of that triangle, main triangle. So then again we have that, since the function is analytic in the triangle delta, and it is also analytic in particular at that point, we have there taken that is which is common to all, which is a member of that delta. Hence, by definition, for every epsilon greater than 0, there exists a delta greater than 0, such that modulus of f of z minus f of z0 divided by z minus z0. Here it is the term is, that is the f dash of z0, should be less than epsilon. Whenever this distance, that is the length is, it is always as compared to this, it is less than this delta. However, it is very small there, even though it is positive there. Then you can simplify this definition of analyticity, so that the modulus of f of z minus f of z0 divided by z minus z0, just we can multiply both by z minus z0 on both sides. So we get an expression this there. So now we consider the left hand side expression of this total expression. So what is this integration? Just by taking the integration, we have here just over the triangle delta n, means what, it is the n number of divisions in the main triangle we have made that. What is that results? Our aim is to find the results of that division, the division there. So now we have there here integration. We are taking integration through this modulus of that expression. So then we arrive at that. So again, if we take individual individual integration each term, since point is an arbitrary point inside the main triangle there, even because so that it is a constant, that is, it means what, it is as good as it is center of that all the sub triangles, which is common to that, which means what, it is constant there. So that's why you can take it, that is z0 is, since z0 is constant, so that f of z0 is also constant. So then we have that integration, this is a constant into integration of delta z dz over a delta n, that means it is a 0 there. Because for any closed curve, so integration of any closed curve, because since it initial and final point coincides with that, so that at which both the results are same, so then it should be gets 0 there. So that's why integration of any function which is a closed curve, that result is here, it is a 0 there. So then we can take it here also, it's a derivative of this f of z0. It is, since it is constant z0, so that its derivative is also constant. So that you take it outside, and again z minus z0 over the closed domain triangle, that is a triangle, so that again it is also 0 there. So only that, so that this is also constant into that, again it is 0 there, since z0 and f dash z0 it is constant. By taking outside by integration of 1 dz over the triangle delta n, it is also 0, and only that is the, this is also, since it is contains and z dz, this integration is also 0 for any closed curve, so that only the expression remains in this integration is this one. So that is what there. Therefore above equation can be written as only the terms, it is remains that here epsilon into integration of z into z minus z naught into dz, because since it is modulus there, so that in the left hand side this is the term. Now we assume that now we can take it to the see that the z minus z naught, it is whatever that is nothing but the distance between the 2 points in a triangle which cannot exceeds the perimeter of that triangle. That perimeter we can take it a ln there. So that means what here, since it contains, it is modulus z minus z naught, it means what, it is the distance between any 2 points in a triangle which cannot exceeds the perimeter of that. So that expression we can take it modulus of z minus z naught less than or equal to ln, and that ln is the length between the 2 points that in that dz is modulus of dz is ln. Hence we can substitute those in the right hand side of that expression, so that epsilon is as it is, and this is the ln and this is also ln. So that because since it is this integration of modulus of dz, it is nothing but it is the arc length of the any curve, closed curve there. So that is also ln. So this becomes, you can substitute in equation 2 that, which get it, there is modulus of that integration of the modulus of the integration of f of z over the triangle delta n less than epsilon into ln square. Now capital L is the length of the perimeter of the triangle, so that that we can take it capital L is nothing but whatever, see that it is the 2 times of that is the length of the perimeter 2. So that is what we have there, capital. So then we can take it, that is the ln is what, that capital L 2n there. Thus we have that you can substitute that these all this ln and everything, so that substitute in that equation, above equation, that equation becomes this form there. So it becomes what, this is 2 to the power of n power 2, it means what it is, again it is a power n. So just we can consider that is the equation 1 here, which have that is everything, it is the whatever that is this integration, that equation 1 which contains the magnitude of the integration of modulus of f of z dz over the sub-intervals of the triangles, so delta n, so that we can denote it by this way. So this is what we have there. And this is because since that is every sub-triangle can be divided into again 4 sub-triangles, so that in such a way that it becomes that is the 4 power n there, and 4 power n times of this. So substitute these results here. Anyway, it should be less than that. It should be less than the epsilon times of L by 2 power n power square there. So that this power 4 power n and this 2 4 power n gets cancelled each other, so that it becomes this what, that is L square into epsilon there. Epsilon, that is the integration of f of z dz over that, and its magnitude is, that is always less than or equal to epsilon into L square there. Since epsilon is very small, you can take it as arbitrary, so that since it is an arbitrary, so then we have make it as a close to 0 there, then it becomes this integration is close to 0 as epsilon approaches to 0, because since epsilon is a very small quantity, so that's why we can take it as it is approaching to 0. As epsilon approaching to 0, this magnitude of the integration of f of z over the triangle d over the triangle, that result is 0 also. So that it is what, it is the integration of f of z over the closed domain triangle, it is always 0 there. This is what it is the today's lecture as we have discussed in this video there. So as in that statement, what it says that since if you have any closed domain, so that even though if it is whatever that is, if it is the only if it is the closed curve, then we have there is no problem for integration of f of z over any domain. It's a 0 there, closed domain, that is a 0 there. So that is what it is there. So suppose the points you can make it as that. So that even though you can take it divisions in any manner, that integration can sum it all the integration, so that becomes a 0 there. because since it is closed, so by this is what it is, the Cauchy-Gauss theorem for a